Control T, and I can manipulate my table to get the values needed. So I went ahead and completed my table here with the values 0, and then pay attention, it doesn't go from -5 to -4, it jumps to -3. So be careful with that. And then you have a -12, a -15, -16, and so on. So here's your whole table. Don't worry about the markings I have around here. I will explain that as we go through this example. So continuing on, I went ahead and after I wrote down my points, I went ahead and graphed them all, and I got the graph of this parabola that we have on the right-hand side over here in purple. So I'm not going to lie to you, it's not easy drawing a curve by hand, especially with pen. But luckily my experience is decent enough that here's the general idea of what our graph ends up looking like. Your calculator may make it look a little narrow, that just depends on its settings. But here's the general idea of what you should get. So go ahead and make sure you get your graph created as best as possible. Now we're asked to highlight the x-intercepts and the point found on the line of symmetry on the table. So the x-intercepts right here at -5 and at +3. So I highlighted them as well over here. At -5, 0, and then +3, 0. That's another reason why they're called zeros, because their y value, or the f of x value, is equal to 0. It's when it hits the x-axis, or in this case, these are x-intercepts. That's why all these words are interchangeable. Next, I was asked to find the point found on the line of symmetry on the table. The line of symmetry is this pink dashed line I drew, and it has to go through the vertex. To get the equation of the line, you take the x value of the vertex. Well, just looking at these numbers here, I can see that my lowest amount it goes to is at -16. So what's the x value for that? -1. Therefore, the equation of this dashed line is that x equals -1 because it crosses the -1 value on the x-axis up and down infinitely and cuts this parabola into equal halves. So now I have all the information written down. I can just basically rewrite everything as I answer these questions. The roots, once again, are at -5 and at 3. The vertex is at -1, -16, right down here. -1, -16. Excuse me. The line of symmetry, like I just discussed, was that x equals -1. We have an obvious minimum that this graph hits before it goes back up. The y-intercept, it hits the y-axis at -15, right here between the 14 and the 16. If you want coordinates, you can see it's at 0, -15. The domain, because this graph continues to stretch left and right infinitely, we have all real numbers. The range, however, the height of the graph, is everything bigger than, but no lower than, -16. Otherwise, y is greater than or equal to -16. Everything greater than or bigger than -16. Including -16 because it does make contact with it, hence the half equal sign. Now I just went back and used my table for my calculator and I got these values. When x was -3 on my table, I have a -12. I used the table itself. You can actually get this from the table up here too for this value. -3, you get a -12, so there's your answer. For 4, although 4 is not here, which is why they left it out, you can just use your table and you get a 9. And then they want to know for what values of x would I get -12s. Well, I get -12s right here and right here, and those values of x are at -3 and +1. So -3 and +1. Let's go ahead and turn our page over. And we have number 3. This is basically the last example that you just did. I would suggest maybe pausing the video here, graphing this equation, and then filling out as much as possible and using this just to verify your answers. Go ahead and pause the video once you've done that. If you already have done that, then here you go. Here's your values. For -x² plus 4, the negative sign tells me that my graph's going to be facing down. There's a little hint for you to help you check if you're doing it right. So one thing I should identify is that a -x² or negative anything x² means my horseshoe or parabola will be facing downwards, which is what I have here. Using this equation and my calculator, I went ahead and filled in all the remaining values and I graphed all my points and I did my best to get this curve. It's a little harder to do the upside down curve for me, but whatever, there's the general idea. And then I went ahead and just like the last example, identified all my important points. I have my x-intercepts at -2 and +2. So this graph's nice and symmetric. It hits at opposite equal numbers. My line of symmetry goes right through here at the y-axis, which is also referred to as x equals 0, because it's right in the middle where x equals 0. And then I have identified the roots here and my line of symmetry here. And then here's just the rest of the answers to the questions. The roots are at -2, 2. The vertex is up here at 0, +4. My line of symmetry is at x equals 0, this orange line I highlighted. It definitely goes from left to right if you read it. It goes up to a max and then back down again, so we have a maximum only. The y-intercept is also at 4 where the vertex is, or 0, 4. The domain, because this graph goes infinitely left and right, stretches forever, it's all real numbers. And the range in this case is everything from 4 below, including 4. So y less than or equal to +4. Everything from +4 on down infinitely, basically. Or all real numbers less than or equal to 4 is another way it could be phrased. Using my table again, when f is -2 on my table, I get a 0 for an answer. I see that right here. When f was 0, right here, I get a 4. And then they want to know what are the two x values when that gives me -5s. I get -5s right here at -3, and once again down here at +3. So now let's go ahead and apply this to a real world scenario. I'm not sure if any of y'all gone to Topgolf yet. I have not. But I have played some golf in my day, or miniature golf at least, because that's who we kidding. I don't know how to do real golf. And here we have an application problem. The height of a golf ball is given by the function f of t equals -16t squared plus 48t. The negative in front of t squared tells me that this graph should be facing downwards, which is what we have right here. And it says time, where t is time in seconds, and f of t is measuring the height in feet. So use the graph to answer the questions and label the independent and dependent quantities. That means we have to label our graph. So time is always your independent quantity. So time is being measured in seconds down here, and our height is being measured in feet over here on the y-axis. The graph's provided for us. So just going from left to right, A, B, C, D order, I'll go ahead and answer the questions. Name the vertex as a minimum or a maximum. So we have reading from left to right, we have a maximum, and the vertex is right here. And if we want to actually get some points in there, we could say the vertex appears at